Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0339, pertains to an intermittent interruption in the crankshaft position CKP sensor circuit on the Honda Civic 2022 and newer models. This issue can affect the vehicle's engine performance and proper operational efficiency, as the CKP sensor plays a critical role in monitoring the position and rotational speed of the crankshaft. This data is vital for the engine control module, ECM, to optimize fuel injection and ignition timing. If the engine's turn sequences are disrupted or out of specified parameters, the powertrain control module, PCM, triggers this DTC to alert the technician. The CKP sensor is typically located at the lower front of the engine block, close to the crankshaft pulley. Proper functioning of this sensor is crucial for ensuring the vehicle's effective operation. The Crankshaft Position (CKP) sensor is responsible for reading the position and rotational speed of the crankshaft, which is essential for the PCM's functioning. It is positioned near the crankshaft pulley, close to the engine's lower front section. When the CKP sensor operates, it sends pulses corresponding to the crankshaft's position to the PCM. If these pulses fall outside specified parameters, the PCM identifies an irregularity and logs the DTC P0339. This indicates that there may be an intermittent problem within the CKP sensor circuit that could affect engine performance, possibly leading to stalling or difficulty starting the vehicle. A full diagnostic should be conducted to locate where the disruption is occurring within the circuit to ensure reliable operation of the engine management system. Several factors can lead to the occurrence of DTC P0339. One common cause is loose or corroded connections at the CKP sensor itself, or the powertrain control module, PCM. Any disruption in these connections can lead to an intermittent signal interruption. Additionally, if the CKP pulse plate, which is responsible for providing the necessary signal to the CKP sensor, is damaged or loose, this could also cause irregular readings, ultimately resulting in the stored DTC. Lastly, it is also essential to inspect the CKP sensor for faults, as a malfunctioning sensor may not accurately report the crankshaft's position, further contributing to this DTC being triggered. Performing a thorough inspection of these components will help identify the root cause of the circuit interruption. The presence of DTC P0339 typically results in several noticeable symptoms affecting how the vehicle operates. One of the most apparent signs is engine stalling, which occurs when the signals from the CKP sensor are inconsistent. This inconsistency can lead to sudden power loss, resulting in difficult start conditions for the engine. Moreover, the driver may notice poor engine performance, characterized by rough idling and hesitations during acceleration. Other indicators could involve warning lights on the dash, particularly the check engine light, which can illuminate when various DTCs are stored. Addressing these symptoms swiftly is crucial to prevent further complications that could lead to more significant vehicle issues down the line. The first step in troubleshooting DTC P0339 involves starting the engine and allowing it to idle for at least 10 seconds. During this time, it is essential to utilize the HDS, or the Honda Diagnostic System, to monitor the OBD status, specifically checking for the DTC P0339. This step essentially focuses on confirming whether the DTC is present after the engine has been idling. If the code appears, it indicates that the problem persists and requires further investigation. This initial monitoring helps in making sure that the PCM is continuously recognizing the same fault, setting a foundation for the next diagnostic steps in the troubleshooting process. The second troubleshooting step for dealing with the DTC P0339 requires a test drive of the vehicle for several minutes while maintaining engine speeds and vehicle speeds within specifically recorded onboard snapshot parameters. By driving the vehicle, you can recreate conditions that may cause the failure to assist in diagnosing the issue accurately. The HDS should again be monitored for the DTC P0339 during and after the test drive. Documenting if the code reappears during this phase is crucial, as it signifies that the CKP sensor circuit remains problematic, even during varying engine loads and speeds. This detailed examination can reveal inconsistencies that may occur during operation, highlighting areas needing further inspection. In this third step, it is vital to inspect the CKP sensor circuit connectors thoroughly. Check for secure connections, focusing particularly on the CKP sensor and PCM terminals. Ensuring these components have no loose connections is crucial, as even slight disconnections can lead to intermittent circuit disruptions that trigger DTC P0339. It is recommended to visually inspect the terminals for any signs of corrosion or dirt, which could also prevent proper electrical contact. If any abnormalities are identified during this inspection, corrective measures must be taken to repair or replace the affected components to restore proper function in the CKP sensor circuit. This next step emphasizes inspecting the CKP sensor circuit terminals, which include both the engine ground and body ground connections. Proper grounding is essential for any electrical circuit, as it ensures a complete path for current flow. In this case, inspect the connections for tightness and also check for any signs of corrosion or damage at these grounding points. Loose or corroded terminal connections can severely impact the performance of the CKP sensor circuit, contributing to the intermittent signal and the triggering of the DTC P0339. Ensuring that these terminals are in normal condition will mitigate potential electrical issues within the sensor circuit. The fifth troubleshooting step involves a visual inspection of the CKP pulse plate, which requires the CKP sensor to be removed beforehand. It is essential to inspect the pulse plate closely for any signs of looseness or damage. This component is critical in maintaining the proper signaling function required for effective engine operation. If the pulse plate is found to be compromised in any manner, it will need to be addressed, either through tightening or replacing the damaged components. A thorough examination of this part can help identify if it is at fault, which may subsequently alleviate the issues reflected in DTC P0339. In the sixth step of the troubleshooting process, the CKP sensor itself is inspected thoroughly to assess its functionality. If all prior components have been found to be in working order and the connections secure, yet the DTC P0339 persists, this implies that the CKP sensor may be at fault. An inspection of the sensor can involve checking its alignment, electrical connections, and overall physical condition. Testing its output signal might also be performed to ensure that it is correctly communicating with the PCM. Identifying a failure in the CKP sensor will confirm it as the root cause of the DTC, leading to appropriate corrective action for repair or replacement. After completing thorough inspections and performing necessary repairs for DTC P0339, it is important to proceed with a final repair verification. This involves clearing the DTC from the system using the HDS and conducting a test drive to assess whether the underlying issue has been resolved. During this drive, monitor the vehicle's performance for any signs of recurrence of the code or related symptoms. Successful completion of this step indicates that the repairs were effective and the CKP sensor circuit is now functioning correctly, allowing the vehicle's engine management system to operate as intended. It is a crucial step to ensure drivers can confidently rely on their vehicles post-repair to prevent potential occurrences of DTC P0339 and maintain optimal vehicle performance. Implementing a regular preventive maintenance schedule is vital. Frequent inspections of CKP components, including the sensor, pulse plate, and related wiring, can identify wear and tear before they become serious issues. Also, it is advisable to check electrical connections and grounds for any signs of corrosion, looseness, or damage regularly. Staying proactive with these preventive measures can greatly enhance the longevity and reliability of the CKP sensor circuit, reducing unexpected breakdowns or performance issues. Every vehicle owner should make it a point to include these checks as part of their overall vehicle maintenance routine. In summary, DTC P0339 signifies an intermittent issue within the crankshaft position sensor circuit of the Honda Civic 2022 Plus. Identifying issues early through a systematic troubleshooting approach is essential to ensure reliable vehicle performance. By understanding and properly inspecting each component associated with the CKP sensor, technicians can pinpoint the root cause of the issue effectively. This will involve checking connections, inspecting the sensor and pulse plate, and conducting verification tests. Furthermore, adhering to proactive maintenance strategies can drastically reduce the risk of encountering similar codes in the future, ensuring that vehicle performance remains at its best. Taking a detailed and careful approach to diagnostics and repairs is key to addressing DTC P0339. Please like and subscribe to the channel. See you next time.